Welcome. In this episode, we will be discussing and implementing selection sort, a fundamental sorting algorithm. It is a simple algorithm to understand and is a great starting point for our series. The core idea is to repeatedly find the minimum element from the unsorted part of the array and move it to the beginning. To begin, let us set up our workspace. We have a simple Java class called selection sort, and inside we will write our main method and the sorting method itself. So let's start off with our main. We're going to do public static void main, and then put our string array for arguments. So we're gonna implement the method in that uh, main function, and then we need to write our sorting method. So we're gonna do public static void. We're gonna call it selection sort, and then inside we're going to pass in an array. I'm just gonna call it A for this example. For example, we will create a simple integer array to work with. So let us use int, we're going to call it data, and that's manually assign it to be 4, 1, 9, 2, 6, and 8. So now let us consider the actual logic of the selection sort method. The algorithm works by iterating through the array. For each iteration, we assume the current element is the minimum. We then scan the rest of the unsorted portion of the array to find the smaller element. If we find one, we update our minimum index. So let us visualize this first. In our first pass, we start at index 0, where the value is 4. We assume that 4 is the minimum to start. We then scan the rest of the array. So 1 is smaller, so our new minimum is at index 1. We continue our scan, but we find that there is no number that is smaller than 1 in the array. So at the end of the first pass, the minimum index is 1. So at that point, the array 419268 becomes 149268. After the first pass, the first element is correctly sorted. To implement this, we create an outer loop that iterates from the start of the array up to the second to last element. This loop defines our sorted and unsorted portions. So first, let us start off with declaring the actual length of the array. So we're going to do we're going to call it n. Int n equals array dot length. Just a. And then we need to actually implement the for loop. So we're going to start with for. We're going to use a for loop for this. We're going to use our index I. For I equals 0. And then I is less than n minus 1. And then we increment I after each pass. Inside the loop, we need to find the minimum element. We declare a variable, and we're going to call it min index, and initialize it to I. This assumes that the current element is the minimum. So let's do int min index equals I. And then after that, we're going to actually find our actual minimum from lines 10 on inside the for loop. Next, we need the inner loop to scan the rest of the array, starting from I plus 1 to find a smaller element. So we're going to use int j for our next index. We're going to set that to I plus 1. We're going to keep going until j is less than n, and then we're going to increment j. So here, inside we need to find if an element is smaller. So we're going to do if a, so the array, if a j, is less than a min index, we're going to set min index to be equal to j, not k. So if we find an element at array j that is smaller than the element at our current min index, we update min index to be j. This inner loop will run through the entire unsorted portion and find the true minimum index. So once the inner loop completes, min index will hold the index of the smallest element in the unsorted part of the array. The next step is to swap the element at I with the element at min index. This places the smallest element in its correct position. So we're going to do that by first declaring a temporary variable. We're going to call it temp. We're going to set that equal to a at the min index. In here. And then next, we're going to set a min index to be the array at I. And then we're going to set the AI to be temp. So that's a simple swapping procedure. So now our selection sort method is complete. So let us call it from our main method and print the results to verify that it actually works. So we have our data already. First, let's print out the original array. So we're going to do that using arrays dot toString, and then inside that we're going to put data. We have to implement our class. So we're going to just label that as well, original array. And then we're going to actually call the method to sort the data, selection sort data, and then let us print out the actual sorted array. So let's run the code now. It'll take a second to build, but as you can see here, once this is done, the array will be sorted. But let us just briefly discuss the complexity. Selection sort has a time complexity of quadratic time, or big O of n squared, in all cases, best, worst, and average. This is because we always have two nested loops that iterate through the array, regardless of whether it is already sorted. So again, this proves why this is a brute force algorithm. The outer loop runs n-1 times, and the inner loop, on average, runs close to n times. The space complexity is constant time, or big O of 1. Not constant time, but constant. Big O of 1, because we are performing the sort in place using only a few extra variables, like temp and our min index. But as you can see here, the sorted array, it's actually sorted compared to the original array. While this is not the most efficient algorithm for large data sets, selection sort is a foundational concept. It simply makes it excellent for learning and for small arrays. In a future episode, we will get into more brute force algorithms that are similar to this. Thank you for watching.